All right, let's see how we can find the answers to very interesting things like cubes and square roots without a calculator. And we get pretty accurate answers. So this question is asking us to find the cubed root of 64.99. Now, without a calculator, that sounds almost impossible. But what if I showed you that we could do it without a calculator? So what we want to do is remember the idea that f of x plus delta x is approximately equal to the actual value of the function plus the derivative times whatever the change is. And it turns out that this approximation will be really, really good. So here's the idea. If we want to find a value close to the cubed root of 64.99, the first thing we need to know is what is an actual whole number that we can use that's close to this. And for example, we know that the cubed root of 64 is equal to 4, because 4 times 4 times 4 is 4 times 4 is 16, times 4 is 64. So that is going to serve as our f of x. We know that f of 64 is equal to 4. That's going to serve as our f of x. Now, our function in this case is f of x is equal to the cubed root of x. Okay, so what we need to do now is go ahead and take the derivative of that. So f of x is equal to x to the third power, which means that f prime of x is equal to 1/3, and I'm going to put the cubed root of x squared right there. I could have put x to the negative 2/3, but that's the same as the cubed root of x squared right here. So let me just show you what this is going to approximately be. Notice, by the way, that our delta x is going to be the distance between 64 and that 0.99. Okay, and so that's going to be our f of x. So here's the idea. It's going to be f of 64 plus our delta x, which is 0.99, and I shouldn't have put the x in there. That's what this is telling us. That's f of 64.99. That's going to be approximately f of 64 plus f prime of 64 times our delta x, which is 0.99. Do you see? That's all it is. And I know that's a little difficult to see, but that's what it's going to be. And so we know that f of 64 is just 4, because we already calculated that. That's the cubed root. Maybe it'll help if I, instead of doing f, if I actually do the actual function notation. So what we got here is we've got the cubed root of 64 plus our derivative of 64, which I just plug in the derivative, 1/3 times the cubed root of 64 squared, which is going to equal, and then we times that by 0.99. So that's all it is. You take your value at 64, add it to the derivative of 64 times your delta x, which in this case was 0.99. So that's going to equal 4 plus 1/3 times 16, because 64 to the 2/3 power is 64 to the 2/3 power is equal to just 16. So 4 plus 1/3 times 16 times 0.99. Okay, and I'll use a calculator, but you can see that this is just some simple multiply and divide. We could definitely do this without a calculator, but we will for now just to speed this up. So 4 plus 1/3 times 16 times 0.99. I do that. 4 plus 1 I'll do this in parentheses. 1 divided by 3 times 16 is 48 times 0.99. And we get an answer of 4.021 if we round it. Okay, 4.021. Now the reason that's really cool is because check out what happens if I put in the actual answer. If I put in the exact answer with the calculator of the cubed root of 64.99, look, if I rounded it to the thousandths place, it would be exactly accurate to our prediction. And so that's really cool. With a little bit of calculus, we can find exact value, pretty close value approximations. This is correct to the thousandths place. And you can do it with just simple multiplying and dividing. And that's kind of a fun idea. Now keep in mind this was partly accurate because 64 is really close to 64.99. As the delta x gets bigger and you get further away from your base case, the approximation, as you could imagine, gets a lot less accurate. All right, I hope you enjoyed that. We'll do one last differential and then wrap up this section.